So you have to remember that impulse equals the area under the force curve in a force versus time graph. So this graph given, it's force versus time. The y-axis is force, time is the x-axis, and the area underneath this curve here will give us the impulse value. Since it's a triangle, you have to use the triangle area equation, which is 1/2 times base times height. So you do 1/2 times the base, which is the time elapsed here, and the height, which is the maximum height in the force diagram. Your total will then be 8.75 kilograms per meters per second. And then you are going to find the final velocity from that. Not velocity, your impulse from that. So impulse equals mass times change in velocity. The mass of the ball, again, is 0.43 kilograms. So you set the impulse equal to that equation. So you'll have the impulse of 8.75, which we found from the area of the graph, times equals the mass of the ball times the change in velocity. So we have the final velocity minus the initial velocity, which was 16 meters per second. So your final velocity is 4.35 meters per second.